Okay, we are going to move on to inferential statistics. So we started with descriptive statistics, which is describing a data set and kind of getting our minds around it, understanding what the data is telling us, so all those different techniques. Then we moved on to probability, which is finding how likely different outcomes are. And the outcome we were really interested in is how likely we were to draw out a sample that had a given mean. And so that was the very last thing we did in Chapter 6. The central limit theorem allowed us to find probabilities for drawing out samples. And now we're going to be able to use that to do our inferential statistics. So we're moving on to the last thing. So this whole unit is about inferential statistics, and we're going to be making inferences about the population from the information we gain in a sample. And we're going to start out by doing estimation and confidence intervals. And so before we actually get into that, I want to talk about something called confidence levels. So when we make a statistical inference, we're never going to be able to be 100% confident that the inference or the conclusion we draw is correct. So you will never gain complete certainty or 100% confidence. But what you will be able to do is you'll be able to have a high confidence level in your estimate. Okay? And these are going to be the main confidence levels we use: 80%, 90%, 95, 98, and 99. And basically, the higher the percentage, the more confident you're going to be in your estimate. And in order to use these confidence levels, we're going to associate with each percentage a critical z-value. And that critical z-value is going to be used in formulas such as margins, such as the margin of error or a test statistic. But that critical z-value is going to play a role in those formulas. And when you see them in the formula, the symbol is actually this whole thing, z with a little alpha over 2 subscript. So that's kind of weird there. Maybe I'll zoom in on that. So that's a z value, like a z. And then the little subscript is the alpha, Greek letter A, alpha over 2. Okay? And that whole thing represents the critical z-value, and you'll see that in the formula. And in place of that, you're going to put one of the z-scores, depending on what confidence level you're using in your estimate. Okay? So basically what I want to do is show you where these z-values come from, how they're connected with these percentages. So let me do the 80% confidence level here. So basically what you're doing is you are going to ask yourself what 2 z-scores gives you the middle 80%. So we actually did this way back in at the beginning of the normal distribution when we used the normal table backwards. So there's going to be like 2 z-scores here, one down there and one up here. And the area between these two, the area between those two, you actually want that area to be 80%. And so what you're actually asking is what z-score gives you the middle 80%. Okay? So if you remember, what we did is we took 100% minus 80%, and we got 20%. Okay, so if I want 80% in the middle, then I want 20% on the outside in the 2 tails. And that's actually known as the alpha, okay, that 20%. And if you remember, we had to divide it evenly, that 20% evenly between the 2 tails, right? So we took that 20% divided by 2, and we got like 10% in each tail. And so that was actually, that's actually the alpha over 2, right? Is that 10%. You have 10% in each tail. Okay? And so now you're going to look up the 10% backwards on the standard normal table. So I'm going to move my decimal point over. And this is what I'm looking up on the table. So let me grab my standard normal table. I'm going to be on the negative side. And so I'm looking in here for 10%, right? Whatever comes closest. And this one comes closest. It's 0.1003. And so I go over here and I get negative 1.2. Up here is 0.08. So putting those two together, what I get here is I get negative 1.28. And this would be positive 1.28. So basically the critical z value here is just the number itself without the negative sign there. Okay, so the critical z value, or sometimes you can think of it as plus minus 1.28. Okay, so the critical z value for 80% is 1.28. And it's the z-score that gives you the middle 80%. Okay, so we could write this, z sub alpha over 2 is 1.28. Okay, so the critical z value in this case for 10%, or for the critical z value for 80% here is 1.28. Okay, so you don't really have to worry about this notation. This is actually where it's coming from. You don't have to worry. I don't want you to worry so much about that notation. Just know that this this confidence level has this critical z value. And then the 90% has a certain critical z value. We'll do one more here. And then if you want, you could find these critical z values. So now I want 90%, right? So maybe here and here. So I want this middle shaded area. I want this to be 90% of the area, right? So my alpha is 100% minus 90%, which is 10%. So my alpha over 2 would be 10% divided by 2, which is 5%, and basically that's 5% in each tail. And then to get the critical z value, I'm going to move the decimal point over 2 places and look up this four-digit decimal area on my table on the negative side, so 0.0500. And if you look here, this is actually halfway between these two right here. There's 0.0505 and 0.0495. They're both 5 away. So the question is, which one of these would you use? Would you use negative 1.64 or negative 1.65? And the answer is you're going to use the negative 1.65. It's kind of like I'm rounding up, okay? So what, oops, this should be 5. So the idea here is you're going to take the critical z value that lies further out. That's going to give you a little more area than the 90%, not a little less area than the 90%. Okay, so this one is 1.65 is what that is. If you want, you could pause the video and see if you could find a couple of these. I'll give you a second to do that. Why don't you pause the video, and then when you come back, I'll tell you what they are. Okay, so let's see how you did. Let's see what you got for these. So the 95% there is 1.96, and I think that number actually appears on the table. You actually find the actual number there on the table. This one here is 2.33, and this one here is 2.58. And so these are the critical z values that go with these confidence levels. So when we start talking about calculating the margin of error and constructing confidence intervals, these critical values are going to come into play. So you might want to put these in a handy place so you can find these real quick so you don't have to do this every time. Most of the problems are going to be one of these 5 confidence levels. These are the most common. There might be just one problem on the homework where you're given a percentage that's different than this, and it's actually going to be a problem where it asks you to find the critical z-value. So any of the actual confidence intervals, it's going to be one of these 5 confidence levels. So in the next video, we're going to talk a little bit about estimation, what that is, and then in the video after that, we're going to actually look at how to construct a confidence interval.